Assalamu alaikum. Hi to all my students. How are you? I hope all my students are in a good health. So now we are going to continue teaching and learning through online medium. I hope you are all ready. So let's start it with the introduction of chapter 4, known as a basic requirement for analysis. The important terms you need to understand in this chapter 4 are the difference between sample, gross sample, representative sample, what is meant by sampling, and what are the correct sampling technique for solid, liquid, and air samples. So at the end of this chapter, I hope you will be able to answer all the questions I asked you earlier. Let's begin. In chapter 1, I have described the 7 steps involved in chemical analysis. While in chapter 4, we will focus on the 3rd step, known as an obtain a representative sample. So, where you can obtain the representative sample? You can obtain it from the whole sample, or also known as a bulk sample. So this representative sample can be taken easily to the laboratory for further analysis. And it believes that the results obtained will be accurate. Next, sampling is a process, technique, or a method to get a representative and homogeneous sample, where representative is the contents of analytical sample that reflect to a bulk or the whole sample content, while homogeneous means that the analytical sample has the same content throughout the analysis, such as bulk sample is a solid, so analytical sample also must be a solid. The analysis may be classed by method or the percentage of constituent in a sample. For method, it can be divided into 4 methods. If the weight of your solid sample is greater than 100 milligram, it can be classified as a meso method. For semi-micro, the weight is between 10 to 100 milligram, and the volume is between 50 to 100 microliter. Meanwhile, for micro, the weight is between 1 to 10 milligram. Ultra micro is less than 1 milligram. While for percentage constituent in a sample greater than 1%, it will be classified as a major constituent of sample, while between 0.1 until 1% classified as a minor, and the trace constituent of sample is less than 0.1%. The last one is the ultra trace in the range of a few parts per million or less, ppm, as I teach you in the first chapter. As I said earlier, sampling is a process to get a representative sample. But there are a few factors need to be considered when you want to obtain a sample for analysis. For example, for the first one, the size of the bug to be sampled. For example, Malaysian citizens that are positively infected to COVID-19. There is a lot of people. So the size of the bug is Malaysian citizen as a whole. Is it clear? So we proceed to the second one, the physical state of the sample, either solid, liquid or gas. And the last one is the chemistry of the material to be assayed, such as in terms of reactivity of the sample towards light, humidity and the environment. Okay guys, always keep in your mind that chemical analysis is usually performed on only small portion of the material collected that need to be analyzed or characterized. If the amount of material is very small and it is not needed for further use, then the entire sample may be used for analysis. So here is what are the materials that can be sampled. It can be divided into three types of common sample, which is air sample, liquid sample, and also the solid sample. Here is a summary of the steps involved in sampling of a bug sample. Start from identify the population from which the sample is to be obtained, followed by collect a gross sample that is truly representative of the population being sampled, and the last step is reduce the gross sample to a laboratory sample that is suitable for analysis. Since there is a star in the slide, so it will indicate that this is one of a favorite question that might be asked in the exam. Pause to ponder. Obtaining a representative sample is the first step on analysis. The gross sample is several small portion of the sample. This is reduced to provide laboratory sample. An aliquot of the sample is taken for the analysis sample. Okay, now we proceed to sampling solid. The main problem for sampling of solid sample is its inhomogeneity of the material. For example, if you want a sample of a pot-decent sea sand, there are many materials and sizes in the sample, such as the tiny stone, sand, shells, and others. The easiest way to sample material is by using the grab sample. Not a grab food, not a grab car, grab sample. The sample taken at random and assumed to be representative. For reliable result, it is best to take 1/50 to 1/100 of the total bulk. The larger the particle, the larger the gross sample should be. The gross sample must be reduced in size to obtain a laboratory sample. So this is the way to reduce gross sample to lab sample by using the coning and quartering technique for solid sample. First step is using the method cone and quarter. You need to produce a conical pile of a sample. Then the second one, flatten the conical pile and cut into half, then into an equal quarters. Take sample from each quarter of the pile. Two opposite quarters are chosen at random. Crush these two quarters of sample and form a smaller conical pile again. The whole step are repeated until a laboratory sample is obtained. So in this part also is a star. Hope you understand. So, end of the online lecture 1, chapter 4a. You can ask any question related to today's topics. Do not hesitate to ask even a silly question. That's all for today. Thank you very much. Assalamualaikum.